Hey guys, I am here with a tutorial of what is vector and scalar quantity, as one of our friend has requested for this topic as a video tutorial. So let's understand what is vector and scalar quantity. I will give you certain example first. Let me talk about some of the definition. It's actually seem to be very complicated, vector and scalar, but it will be very simple as we go on through this video lecture. And I will also give you a bunch of example, and example will make the thing super clear, I hope. So hopefully we are going to write some definitions about the vector and scalar quantity. So vector is a quantity which has magnitude as well as direction. In addition to magnitude and direction, it also follow the vector law of addition. So when we talk about scalar quantity is a physical quantity which has only magnitude. And it do not have any direction. So let's take about the example. Before that, what we try to understand, what is magnitude. Magnitude is something we called size, dimension, quantity, or any numerical value any numerical value which is used to represent the any physical quantity. So the numerical representation of any physical quantity is called its magnitude, and the direction is the sense of the, or the line of, or the force of action, or the motion, the direction of the motion. So let's understand through an example. Suppose we have a table here and we have a block and now we move the block in the right side at a distance of 5 meter. So here we say that we have moved block a distance of 5 meter. So here we are saying that the 5 meter is a numerical value. 5 meter is a numerical value and it is called magnitude. So now we can say it in more convenient way and more easy way, that we have moved a block 5 meter in right direction. In right direction. So here the 5 meter represent the numerical value, that is our magnitude, and the right direction represent the direction. So when we say that we have moved the block 5 meter in right direction, we are actually saying that the block is displaced 5 meter in right direction or right side. So here it is a vector quantity. When we talk about a scalar quantity, we are simply saying that the block is moved at a distance of 5 meter. We are not specifying the direction of the block. So I haven't tell you about distance and displacement, so we have another tutorial on some of other days depending on our classes. So I am just saying that I am just making you understand that the displacement, which is the shortest distance between initial and final point. Shortest distance between initial and final point. And if you are talking about distance is the total path covered. I hope you all know what is path. It's like every student know. of your classes and of your ages. So pardon me about my writing. It's actually bad, I know that, but I am making it clear through the voice, so just understand. So displacement is a vector quantity and distance is a scalar quantity. So I hope you have cleared about the vector and scalar in terms of distance and displacement. If we say that at time t equal to 0 the block is at point A. Now at sometime t equal to 2 second, means time started with the 0 and after 2 second the block we will be able to move at point B. So the block move at a distance 5 meter in 2 seconds. So here we come with another quantity, that is block. We will be able to move the block 2.5 meter in 1 second. Now we can say that 2.5 meter per second is magnitude. So if you are saying that the speed of the block is 2.5 meter per second, then it is a scalar quantity, and scalar quantity is called speed here. If we are saying that we will be able to move the block 2.5 meter per second in right direction, now here we call it as velocity. So here 2.5 meter per second is the magnitude and right direction is the velocity. So I hope I have made clear about what is the distance, displacement, velocity, and the main thing we are focusing about is scalar and vector. So we are again revising the definition. Vector is a physical quantity which has magnitude as well as direction, and now you will be able to easily understand what is magnitude and what is direction. And scalar is a quantity which have only magnitude, no direction. Apart from these vector and scalar quantity, we have another third quantity which is called tensor quantity. I am not going to much detail about the tensor quantity, just simply making you understand there are certain quantity which has both magnitude and direction but does not follow the vector law of addition or the triangle law of addition. What is triangle law of addition we will be dealing in some other lectures, but just understand that it is not a simple addition, it is something related to trigonometrically addition. So tensor quantity is a vector as well as scalar quantity, but it does not follow the triangle law of addition or the vector law of addition. So we introduce such quantity as a tensor quantity. Now for example, current. We are talking about the current. Current is the flow of electron in a particular direction. So it has both magnitude 1 ampere current, 2 ampere current, and the electron is moving in a particular direction. So we have your direction, but it does not obey the triangle law of addition. So we call it as tensor quantity. Tensor quantity is any physical quantity which has both magnitude and direction but do not follow triangle law of addition. So tensor quantity is mainly defined as tensor quantity is a geometrical representation of vector quantity, scalar quantity, or some other tensor quantities. So I hope I will be able to understand all your doubts in this topic. Hope to see you in the next video with some other topic. Thank you, and please do share our group, and just thank you. And if you have any doubt, please mention your doubt in the comment. We hope to clear your doubt with much more detail. Thank you.